Well, good afternoon, everybody. Today is the first day of school for the fall 2024 semester. This class is ES 2110 Statics, so welcome. This class is a hybrid class, so Mondays at 1 o'clock, unless the schedule says differently, we will meet face-to-face in SM 135, and other days we will meet virtually, and it'll actually be asynchronous for the rest of the week. Now, I'll talk to you about how you can get a hold of me and how you can work with me outside of the hours that we have together. But rest assured, I will be here a lot. So let's take a look at the syllabus for this class, and then we'll go through the procedures. The syllabus for this class just tells us that we will meet in SM 137. That will be on Mondays. And then we'll do Zoom on Wednesdays and Fridays most of the time. But my name is Astrid Northrup, and my office is here in the Math and Science Building, room 126. The Zoom location for our class is here at this Zoom address. And you can always schedule an appointment with me if you can't find me on campus through the Calendly link right here. So I keep my I don't really have like standard office hours. Like if you go to my office door, it doesn't say I'll be here Tuesday from 2 to 5 or anything like that. But I'm available a lot on Calendly, and Calendly keeps a calendar, obviously, so it tells you what hours are available. And the good news about Calendly is if you use it, nobody else can really schedule over that time, not even my supervisor. So you're entitled to that time, and we can get a lot done because we won't have any interruptions. The other thing is Calendly defaults to being a Zoom meeting. But if you want to meet me in my office, just send me a note and I'll make sure that I am available and have that time set aside for you as well. So you can get a hold of me by email is the best way, or you can text me. My cell number is 307-272-1833, and you can text anytime. Please don't leave a voicemail. I will never find it. So the way to get a hold of me is to send me a text or an email, and I will get back to you very quickly. So what do we do in statics? Well, the answer is statics is the first of several courses that discuss a body of math and science and technology, which is called vector mechanics. So vector mechanics statics deals with things that sit still or don't accelerate. Vector mechanics dynamics takes care of things that move. Then we also have mechanics of materials, which talks about the internal responses of structures and structural elements to load. And then fluid dynamics, which is also fluid mechanics, fluid dynamics, just talks about how fluids behave under some of the same ideas. So statics is the first of this 4-credit sequence. In order to be in statics, you need math through Calculus 1. Although if you are currently in Calculus 1, if we have a visit, I can describe to you what needs to happen in order for you to stay in this class. But if you've completed Calculus 1 successfully, then you are golden. What we want to do in this class is to understand vector mechanics considerations and apply these principles to non-accelerating engineering problems. Items that move at a constant speed and items that sit still behave more similarly than items that accelerate or where the speed is changing. Not just speed, but the direction. Speed is a magnitude of velocity. So I should say velocity is changing, because it could just be a directional change as well. But if things have no change to velocity, whether that no change to velocity is velocity of 0 or some other number, they sort of behave the same way. And if things accelerate, they behave in a different way. Or there are more things that you have to take into consideration. So here we're going to talk about non-accelerating problems. In other words, the change in velocity is 0. We gain factual knowledge and terminology, develop the thought process and methodology required to interpret, analyze, and solve engineering problems to the level and in the manner that will be required of students in engineering courses from this point forward, and to present solutions in an industry standard format. So there's two parts to this that I want to stress, and anybody who's gotten through calculus is already halfway here. But in engineering, an answer is never a number. It's a number with something else. It's some work that shows how your thought process went together, and it's a number and a unit, unless it's a dimensionless constant. So the reason for that is when we're talking about engineering analysis, we're really talking about describing the real world mathematically. So the theoretical part of math, where you might present a number and it would be a complete answer, it's kind of in the rearview mirror for us. So we need to talk about, $500, 600 pounds, 300 feet per second, and so forth. So we spend a lot of time working on units, which are how we express physical dimensions. So we talk about dimensions to a lesser extent in this class, and units quite a bit. The text that we use in here is Vector Mechanics for Engineers Statics, and I have the 11th edition, but really the 12th edition or another edition will work okay. And even though my camera I have it on a reverse thing, but this is the way, this is the 12th edition of the textbook. This is Statics and Dynamics. One of your classmates found out that he could get the statics and dynamics combined for less money than statics. So that's a good solution. The only thing you need to be careful of is, as you probably know, most of the rest of the world uses the metric system, or it's called the International System of Units, or SI. So some textbooks don't have what we use, which is called the US customary system or English system. And it's very important that we learn both. So if you have a textbook, make sure that it contains both sets of units and you will be good to go. All right, so the topics we're going to cover: vectors, forces, equilibrium, centroids, moments of inertia, fluid statics, trusses, frames and machines, and friction. So some of those things may be familiar to you through either math or through physics, but if they're not, it's not a problem. As long as you've got enough math to do the work in here, you will be great. The grades in here, we'll have homework I'll describe the process in just a minute when I show you it when we go to the Moodle page, but we have homework, which is worth 10%, quizzes, which are worth 10%, a midterm exam, which is a 2-hour exam proctored. That means we can proctor it online on Zoom, or we can proctor it in classroom, one way or the other, in 2 hours, or we can do 2 1-hour blocks. That's worth 40% of your grade, and the final exam is also worth 40% of your grade. Now, it looks like the midterm and the exam are very heavily weighted, which they are, but the purpose of doing the homework and the quizzes is to get you ready for the midterm and the finals. So if you do the homework and you do the quizzes, you will be set and prepared to take the midterm and the finals. So that's kind of the reason. I have had students who have attempted to come in and take the midterm or the final exam without doing the pre-work, and I'm sure that people who can do that exist, but I've never met them. So please do your homework and do your quizzes. Generally, overall percentage of 90 to 100 is an A, 80 to 90 is a B, and so forth. And I will guarantee those numbers. If you make a 90.0%, you're guaranteed an A. If you make an 89.4, you may get a B, you may get a B plus, you may get an A minus, or you may get an A. So I reserve the right to round up. Never, ever, ever do I round down. So those are guarantees to you, and you might get a little bonus if you do all your work and everything distributes itself properly. And so I take those things into account. So the homework policy, everything has to be turned in through Moodle, and everything has to be on engineering comp paper. I'll show you a little bit about what your homework needs to look like, but an answer with, even if you have a number plus a unit, if you don't show me your work and show me a diagram and explain to me how you did it, which is called mathematical and graphical reasoning, you will not get full credit. And you may get full credit or nearly full credit if you have an incorrect answer, if your reasoning is good. It just depends on the mistake. So I always look at every problem as being an essay question. So the work that you do to get to your answer is just as important as the answer itself. Please make sure that you turn in the homework as either a PDF or a JPEG file. I really like PDF the best, but if you have an Apple phone, it will default to taking pictures in a format which has extension HEIC. It can't read them, so please don't turn it in that format. Also, don't email it to me unless there's some crazy thing that I don't know about. So what I'd like you to do every single time is send me a PDF or a JPEG right to the Moodle account. So having said, or to the Moodle page. So let me show you how this works. Everything is going to be on our class page, the 24 Fall Statics ES 2110 page. So you'll see, for example, the syllabus is right here and the homework template is right here. The homework template shows you how I want you to do your homework. You'll notice, like, if you're in a math class, you may have 30 problems to do for a homework set. In here, you may have 10 or 11 problems to do. And it's not because it's easier or quicker, it's because I want more stuff. Okay, so at the top of each page, write the due date, or write something that determines what this homework assignment is. And then your last name with your first name, and then the page number. So there'll be several homework assignments, like we'll do a few sections and you'll do some homework and a few more sections and do some homework. But the homework comes in as a single unit at the end of every chapter, okay? So when you do chapter 2, you may have 3 homework sets from your work, but they'll come together as a chapter 2 homework. So you'll put them together, and if you have like 3 pages and 4 pages and 3 pages, you'll have, the first page would be 1 out of 10, the second page would be 2 out of 10, and so forth. So then you put the first problem, you identify or summarize the problem, give me a sketch or a free body diagram. You list the theory or principle used, which is really pretty quick and dirty in this class. It's usually summation of vectors, summation of forces in one direction equals 0, summation of forces in the other direction equals 0, perhaps moments, summation moments equals 0, but that's kind of the theory. List any assumptions and then do the math. Then your answer must be reported to the proper number of significant figures. I'm okay with an extra digit or 2, just because we're not in chemistry class where we're measuring micrograms of things. However, if you put in 11 significant figures for something that's a 2 significant figure problem, I will bring it to your attention. Anyway, so you have a number plus units, you indicate that. I always underscore them. Some people like to circle them or put an arrow, but put them removed from the problem so I can see it very quickly. And then you do not have to have a new piece of paper for every problem. You may, but if you want to start the second problem on the same piece of paper, that is absolutely fine with me. That's a personal preference. Now, I also keep that paper, the engineering comp paper, there's stacks of it outside of my office, and you are welcome to use it for this class or for other engineering or math classes that you may have. So if you come to my office, you'll be able to get some paper really quickly. All right, so our conversation today, this lecture will be posted right here. If you zoom into class, or if you need to meet with me, here's the Zoom link for that. If you need to schedule an appointment, this is the Calendly link, so you can see when I'm available and schedule an appointment. And like I said, it will create a Zoom link for us, but if you want to come to my office instead, just send me an email and let me know. The first thing that we're going to do is to talk about unit conversions. So you'll see this link is a lecture. It says it's on Friday, January 20th, but it's really on Friday, August 23rd. So I'll change that date. So watch that. And then here's another lecture for the next day, which are some unit conversions. I'm going to skip the schedule. We'll talk about this in just a minute. And then here's the textbook for chapter 1, review notes. Here is the homework itself, the unit conversion handout. So if you look at that, there we go. You'll see that there are several problems. It's 2 pages, and you just want to do all of these problems. If you have any trouble reading the numbers, let me know. But if you can't read them and you make a false assumption about what a number is, a digit is, I'll give you full credit for that. My handwriting is not going to cost you points on your homework. But anyway, when you're done with that, so you open this up, you watch the videos, you learn how to do it, you do the homework on comp paper, and then you submit it right here. So the due date for that is September 5th, which seems a long way away, but trust me, it's not. It's right around the corner. So that's the deal. So anytime you see the submit button or the assignment button, that's where something needs to be turned in to me. So turn in your homework through that button by the 5th. And in the meantime, you can glance through the textbook, you can look at the review notes, and make sure that you watch the lectures so that you have the information that you need to do that well. And then the other thing I want to say, I don't want to make too big of a deal of this, but I really appreciate homework coming in on time, but if there's not a cutoff. So in other words, if you turn it in a half a day late, you're still going to get full credit. So it's not like midnight comes and it bumps you off, so there's no cutoff date. So please keep that in mind as well. As you're working ahead, don't get discouraged. If you're a little bit behind, you're still eligible for full credit. All right. So here's our schedule for class, Monday, Wednesday, Friday. And there's 3 modalities that we could meet in: face-to-face, asynchronous, or sometimes synchronous Zoom. But for example, today is face-to-face or async, and Friday is just async. Monday is just face-to-face. Now, anytime that we're face-to-face, I'll also have a camera on. So if you're elsewhere and you want to zoom in, you are welcome to do so. And it will also be always recorded on our Moodle page. So even if you're not here, you can do that. But it gives us a little structure. If we have an hour a week, at least, where we get to meet in the classroom, you can ask me questions. We can get things cleared up. We can make sure that you don't have any issues that aren't making sense and so forth. Okay, so homework 1 handout is due on Friday. This is the 30th of August. Okay, I got to change that date. I got the wrong date. So it's due the 30th of August, which is even quicker. I like the 5th better. I don't know. I'm probably going to change this and leave the other one. So let's look. It will be the 5th of September. And then homework for chapter 2 was going to be due the 13th of September. So you notice that homework 1 is just from the handout. There's no homework in chapter 1. So we're going to do the handout. Then we'll do chapter 2 homework. Then we have a quiz over chapters 1 and 2, which I'll show you how that works. Then chapters 3 and chapters 4 homework, and then we have the midterm exam. The midterm exam will be taken either in class or on Zoom synchronously. And I'll proctor that. So if it's best if you come here, because then if you have questions, you can just ask me and we can get everything cleared up. But even if you're on Zoom, we can still do that. But it does have to be a proctored item. So nobody's taking that asynchronously. Okay, so if you talk about homework, what about the quizzes? There's only 2 quizzes in the class. So we do chapter 1 and chapter 2 homework, and then we have a quiz. We do chapter 3 and 4 homework, we have the midterm. We do 3 more chapters, 6, 7, 8, and have a quiz. Then we go back and do chapters 5 and 9 and have the final exam. But how it works is at the bottom of the section for the homework for chapter 2, you'll see a quiz. Now you open the material for the quiz at the green button, but you're going to take the engineering comp paper and work the problem out on paper. So in other words, you don't submit the answers through the quiz. Pulling open the quiz is just for you to have that material. Then when you're done, within an hour, you submit that work, just like you would a homework assignment, okay? And you'll be graded. So I grade the quizzes much more carefully than I do the homeworks, mostly for format and for, not just format, but for your thought process. And then the midterm and final exams are actually graded quite carefully. So if you go through this and you see notes, like for example, I worked problem 2.9 on one of these and I made a boo-boo where I just had the cosine of A over the sine of A is equal to the tangent of A, when in fact it's the reciprocal. So that would be the cotangent. So if you follow the work, there's just a little point. So when you look at that and you think, when did the universe change and the cotangent, the tangent became the same thing? Never, it was just in my head that day. So we'll get done with that. And then right now, chapter 3 and 4 are hidden. That's why they're grayed out. So from a student's point of view, you can't really see that yet. But if you do get ahead and you want to get started on chapter 3, I'll open it up to you. Otherwise, I'll open it up to you after the quiz is done. So, but if you get ahead, let me know and we will move forward from there. All right. So the schedule lays out the dates. It doesn't have exactly if we're going to be doing face-to-face or asynchronous or what on every single Monday, but it does have the due dates for all of the homeworks, both of the quizzes, the midterm exam and the final exam. So everything's laid out to the end of the semester. All the lectures are available, and then we'll do this face-to-face or synchronous part to make sure that everything is current for this semester. And the rest of the material is kind of this perennial material that's posted. So if you watch the videos and you read through the notes and you do the homework, you will be absolutely golden when it comes time to take the quizzes and the final and the midterm. So do you have any questions for me at this point? It's all kind of the same, isn't it? Right, so that's what I strive for. I strive to make all my Moodle pages look just the same and everything the same. The only problem, I try not to make everything due at the same time, but that's the harder part because when you break it up this way, everything kind of comes due. But that's also why I don't get too picky about if you're a little bit late, because if you're working on statics and engineering computing and everything comes due at the same day, it's just a nightmare. So you don't want to do that. All right, so that's it for today. I'll be in my office. I'm doing a physics lab this afternoon, but I'll be here for a while and then I'll be back in my office tomorrow and most of the day Fridays. So if you need me, just give me a text or set up a Calendly appointment or just drop by and we'll get you squared away. All right, I'm gonna go ahead and stop recording. There we go.